Hello friends, welcome to the 7th tutorial of SAP 2000 V14. Today I am discussing about time history analysis, that is non-linear time history analysis for a isolated building. And today I am dealing of example of problem O on the help option. So let me come to the model first. Open, file, open, new model. First let me change the units into kip feet and choose a 3D frame over here. So number of bays in the x and y direction as per the example is 2, and bay width is 30 and bay width is 30 in the x and y plane, and I am trying to give dampers, rubber dampers at the bottom of the foundation. So I am removing the restraints to the member. So I'll say OK. So now you can see the picture of the member. So let me go to the help option, contents and index, example problems, problem number O. So if you see the model here, it is 30 feet of each bay and 12 feet of height of each floor, and 10 inches of thickness of the ground floor and the first floor, and 6 inches of thickness on the top roof. And the beam dimensions are shown here of 24 inches into 55 inches, and columns of 14 inches width into 90 inches of depth. Okay. So first let us click XY plane. So first let us try to assign a area command for this area. So Z0 denotes the bottom floor over here. So let me go to the Z is equal to 12th floor or first floor, that is 12 feet of height, and next go to quick draw area element command. So let me draw a area here, and again go to the top roof member and you draw a area here. And after this is done, you can go for the set select mode. So now I will try to give a damp restraints to the members over here. So before doing that, let us change the unit into kip inches feet. Remember, I am doing all the examples as per the examples given in the help option, but however after completing all the examples in the help option, I will go with the tutorials so that you can understand the insights of the designing aspects. So go to define option. Before going to define option, you go to the bottom floor, that is Z is equal to 0. So you go to define, you can go to section properties, you can go to link support properties. In this you can go for add new property, and in the link support you can go for rubber isolator and you can specify. Okay, now the mass in this case is 0.01, and now what you can do is you can go to the directions command and you can go to modify show for U1. You can go for, you can give an effective stiffness as 1000 over here, and you can just say OK. You can go to U2 and check non-linear case, and you can go to modify show command. In that, effective stiffness of 1.5 is provided, and stiffness in the properties used for non-linear analysis case, a stiffness of 10 is given, and a yield strength of 5 is given, and a post yield stiffness of 0.2 is given to the member. Just say OK. Now go to U3 and again repeat the same process. Go to modify show and again give a effective stiffness of 1.5, and you can give a stiffness of 5 and yield post yield stiffness ratio as 0.2, and you can just say okay, okay over here, okay. And now you have defined the restraints. But if you want to assign the restraints, go to define, sorry, you go to view, go to draw one joint link. You can select the members over here and you can see the restraints are being assigned to the member. Okay, see the restraints are assigned to the members right now. So I will go to the set select mode option, and what I will try to do is I will try to define the sectional properties for the members. So what I will try to do is I will go to define materials, and in the materials I will first design a steel material, that is add modify show material. In the modify show material, please change this as steel so that there will be no confusion. And a modulus of elasticity of 29,000 is given here, and a 0.3 of Poisson's ratio is given here. So you can just say okay, and you can also go to 4000 psi. You can go to modify show material. You can just say it as concrete. Okay, we'll come back to the concrete by changing the units here. Okay, I'll just say okay and okay. And now I want to assign how much of thickness is given to the roof and how much of thickness of slab is given to the floor. So before doing that, I should assign the properties to the member. Go to define, you can go to sectional properties, you can go to area sections. In the area sections, you can go for add new sections. In the add new sections, you can just type as roof, and see that the concrete has been specified over here, and a thickness of 6 inches of membrane and bending is selected, and just say okay. Again go to add new section, go to floor, 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 and you can see the concrete is given here, and you can just specify the membrane thickness as 10 inches by 10 inches, and you can just say okay. Okay, but now you try to change the units into kip feet F, and now you can change the material properties of concrete. See that concrete has been highlighted in the material box, and you can go for modify show materials. In the concrete, please see that a mass per unit volume is 4.662 E or -0.3, and a weight per unit volume of 0.15 is specified, and you can just say okay. You can just say okay over here. Now you can click on the XY plane at Z is equal to 0. You can go for the first floor, and you can select the floor areas over here. Okay, before doing that, what I will try to do is again I will try to change the units into kip inches feet, so that I can define the sectional dimensions of the columns and the beams. So what I have done here, I have went to for define options, sections, frame sections, and you can just say add new property. In the add new property, in the frame sections property type, please select concrete and go for rectangular section. And now for the section name, give the beam and the column. So first I will try to give the specifications for beam. So depth would be for a beam is 55 inches and a width of 24 inches. You can just say okay, and again you can go to add new property. You can just say rectangular, and you can go to a column member of width 14 inches and depth of 90 inches. That is of 90 inches. A depth of 90 inches has been provided to the member, and you can just say okay and okay. And now you can go to you can change the units here to kip feet foreign heights. Just a second. Okay. Keep feet foreign heights. Now what I'll try to do is I will try to go to a XY plane view, that is sorry, a XZ plane view. So XZ plane view is displayed here. What I'll try to do is I will try to come to the front elevation over here. Front elevation would be this. So y is equal to -30. You can go for the perspective toggle view so that you can see the entire structure. Now what I'll try to do is I will go to select. You can go to select again. You can go to select lines parallel to. In the select lines parallel to, go to coordinate axis or plane. You can just select y axis, and you can just select z axis because z is a vertical axis, because now I am trying to assign column dimensions to the member. So see that all the columns has been highlighted. You can go to assign, you can go to frame, you can go to frame sections and see that the column has been highlighted, and you can just say OK. And now all the columns has been assigned, and by default fsec1 has also been assigned. But don't worry about that. Again go to assign, again go to select again and select lines parallel to coordinate axis or plane. In that you can uncheck the z plane and you can select x and y planes, and you can just say OK. And now you can see all the xy planes have been selected on each and every single floor. Now we can go to assign frame sections, and you can just say beams, or you can just highlight the beam sections over here, and now you can say OK. And now before going further of assigning into loads, I want to assign the roofs sections and the floor sections to the given drawing. So what I'll try to do is I'll come back to this frame section properties. I will go to a XY view and I will try to uncheck this, and now I'll go to the top section and I'll select all the areas over here. So I'll select all the areas over here. So after selecting all the areas over here, you can go to assign, you can go to area, you can go to sections. You can just say the top floor as roof, and you can say OK. And now the roofs has been assigned to the top floor. Now go to the first floor, and now you see this has been selected. And now we can select the area of the members, and now we can go to assign area sections, and this will be the floor section. You can just say OK, and now the floor section has been selected. So in order to remove these names on this, you can just go to show undeformed shapes, or you can just simply press F4 on the member. Now what I'll try to do is, sorry it got a bit boring. So far I have specified the dimensions of the member, I have specified the thickness of the slab, and I have specified the thickness of the beams and the columns, and I have given all the assignments to the members, and also given dampness part or the restraints part with dampers to the supports. Now I will try to define load patterns. The load patterns, I will give a load pattern of live load, and I will type live over here. In the type case, I will select live from here, and I will just say add new load pattern, and I can just close this window and say OK. And before proceeding further, I will change the unit into LB feet F. And now you can select Z is equal to 12. So select the entire area, and you can go to assign, you can go to area loads, you can go to uniform shell, you can specify, see that the load pattern name is dead load, and you can give a load of 150 kilonewton, 150 lb, and you can just say OK. And if you see, the lb has been assigned, and you can just press F4 on your laptop or on your desktop, and again you can go to previous selection, again go to assign, you can go to area loads, you can go to uniform shell, you can select live load and you can just say 100 lbs or 100 lb is as per the example, and I'll just say OK. And again you can go to F4 in order to not see the namings of the member. I will go to the Z is equal to 24th floor. Now I will try to select the entire section, or you can just select all the entire section. Sorry, don't do that. You can just clear up everything, and you can just drag the window for the icon for whatever frame that you are seeing on the XY at Z is equal to 24. You can go to assign area loads, a uniform shell. In uniform shell you can choose dead load and specify a load of 75 lb, and you can just say OK. And again you can press function F4 in order to remove the namings on the members. Again you can select the entire wind by dragging the window, or you can go for previous selections. Again you can go to assign, you can go to area loads and uniform shell and give a live load of 20 lb as per the example. You can just say OK. Now all the loads have been assigned to the members. And now I will try to change the unit to keep feed F. Now what I will try to do is I will try to select all the parameters in this floor of the first floor, and I will transfer it to the ground floor or the basement near the restraints. So let me go to Z is equal to 12 over here. If you see, it has been selected, or you can just see view, set 2D view. You can just say this has XY plane, and you can just say OK, and we can just go for removing the things over here, and you can just select the entire members of this panel, and you can go to edit, replicate to a depth of -12 feet. So now the entire member has been transferred to the bottom floor. Now I want to give joint constraints to the member. So let me go to the first floor, and I will go to assign. Sorry, I'll select all the members. I will go to assign. You can go to joint and constraints, and you can just select diaphragm over here, and you can go for add new constraint. And in the constraint, please see that the Z has been highlighted. I change this as first, and I'll say OK. Okay, now this has been selected. Now I will try to go to the Z is equal to 12. So Z is equal to 12 now, or you can uncheck the restraints first of all, and you can go for Z is equal to 12, and you can go to and you can select all the entire window over here, and you can go to assign, you can go to joint and constraints, and you can go for diaphragm and the choose constraint type to add. You can go to add new constraint, and you can just type as second over here, and see that the z-axis has been highlighted over here. OK, and just say OK. And now I want to give time history analysis to the member. Before, let me go to time history analysis, go to define functions, time history. So in time history, you can go to choose function type to add. You can go to from file. So here you can go for add new function. So type here as LAAC0 and browse. In the browse option, so select time history analysis and just say open. You can see nothing has been opened here, but see the data files have been selected here. But go to all files over here, and you can go to, you can come down till LACC North 1, and you can just say open. And you can type header lines to skip to 2, and you can type number of points per line is as 8 as per the example, and the intervals or the values at equal intervals can be given as 0.02 for the values area, and you can just say okay. Again you can go to add new function. Again you can go LACC, you can just say 90 over here, and you can browse, and again go to data files. You can go to all files, and again you can just say LUC2 and you can say open. But be careful, if you are not able to see anything over here, you can just type file name as time history analysis, and then you can just say open, and if nothing is open you can just go to all files and you can do the same thing again. Okay, so please take a note about that. Don't worry if nothing is being displayed, and do the process which I have just said to you. And you can give the header line strip as 2, and number of points per line would be 8, and values of equal intervals would be 0.02. You can just click OK on the member, and you can just say click OK on the member. Now before going further, I want to these cases to the member. So I will go to define menu. I will go to section properties, go to define menu. You can go to load cases, and in the load cases you can select the model, and you can go for the modify show load case. In the modify load case, see that the grid selection has been highlighted, and in the loads applied, load name is dead and maximum cycles is 0. Target dynamic participation ratio is 99%, and you can just add to the section. And again you can go to load pattern over here. You can go to Excel and you can select UX from the member, and you can just say add to the member. And again you can go to Excel. Again you can say load name as UY, and you can just press add. And before closing it, again go to load type, go to link, and just say add. See that load name all has been given over there in the load name box, and you can just say add and say OK. Again go to add new load case, and in the add new load case you can just give GRAV, that is gravity, and here you can go to load case type as time history, and analysis type as nonlinear analysis. In the load pattern type, name as RAMPTH ramped, and you can just add to the selection list over there. And now see that number of output time steps is 100, and output time step size is 0.1, and you can just say OK. And now you can go again to add new load case, and in the add new load case you try to give LAC to the member, and again you can go to load case type as time history and nonlinear case, and again in the load pattern, in the load type select Excel, and you can select U1, and the function name as LACO, and the scale factor is 1. Please change it to 0.0328. Add, Again the load type is axle, load name is U2, and the function is lag 90 and the scale factor is 0.0328, and you can just say add, and before closing that, number of output time steps is 3000 and the step size is 0.2, and you can go to model damping, you can go to modify show, and here please see that the constant damping for all modes is 0.05 and a damping of 0.02 is selected, and you can just see mode as 1 add, you can go to mode 2 add, mode 3 go to mode 3 add it, and you can just say OK, and again say OK, and again say OK. Now please save the file, Ctrl S to save the file. I'll give it as frame time history analysis. Save as per your wish. Save, and you can go for analysis, you can go to run analysis, see that actions for all the cases are in state of run, and you can just say run now. Now the analysis part is almost over. Now we should come to the results part. So analysis completed, that is, then close the window. So what you try to do is you try to select the center node of the ground floor, and you can go to deformed shape and you can select the XY view, and in the XY view you can go to the top floor and you can select the center node. We'll try to see the displacements of these members. So go to display, show plot functions. In the show plot functions you can go to LAC and you can go to define plot functions, and you can select joint 13. You can go to modify show plot functions, and you can see that UY option has been checked here, and you can just close the window. Again select joint 15, again go to modify show plot function, joint 15, again select UY component and just say OK. And now go to add base functions, you can go to add plot functions, and you can select a base shear of Y on the checkbox, and you can just close the window, and now you can just close the window here. And now select joint 13 and joint 15, and you can just say add, and you can just change the vertical and now you can just go to display option and you can see the results here. There is not much deviation occurred and it is very minor over here. The displacement plot functions are very small. That means the joint, the node at the center of the ground floor and the top floor node, there is no much displacement observed in the member. I'll just close this. What I'll try to do is I will try to deselect both the vertical functions here into the next side, remove. I will try to go to base shear Y. And add it, and again select joint 13, I can add it, and now I can go for display option over here. So there is no much displacements. So displacement plot function, there is no much displacement observed for both the nodes. If you want to see for joint 15, you can remove this and you can select joint 15, you can add it, and you can see the display option over here. So you can see minimum is -1.78 e plus 0.2 e to the power of 0.2, and maximum is 1.775. So it's okay. So it is done. You can say it's done. So this concludes the 7th tutorial on SAP 2000 V14. Please subscribe to the link below so that any videos that I am posting can be updated to you. And thanks for watching the video, and thanks for looking into the tutorial. Thank you. Have a great day.